They are in your phone, your laptop, your earbuds, your car keys, and increasingly in cars themselves. Batteries quietly power almost everything in modern life. But have you ever wondered what's actually happening inside that little sealed cell? How does it store energy for months, then release it the instant you flick a switch? The answer is a tiny, elegant piece of chemistry. Every battery, from a tiny watch cell to a giant car battery, has the same basic design. It has two ends, called electrodes. One is the negative end, the anode. The other is the positive end, the cathode. And between them sits a special chemical paste, or liquid, called the electrolyte. These three parts are the secret to the whole thing. Here's the heart of it. Inside the battery, a chemical reaction is itching to happen. At the negative anode, this reaction leaves behind a buildup of electrons, tiny particles of negative charge. They crowd together, repelling each other, all desperate to escape and rush over to the positive cathode at the other end. The battery is, in effect, a loaded spring. But there's a catch, and it's a clever one. The electrolyte in the middle blocks those electrons. They simply cannot flow straight through it to reach the other side. So the electrons are stuck, full of energy with nowhere to go, until you give them a path. And that path is your device. The moment you connect the battery into a circuit, say switch on a flashlight, you hand those trapped electrons a way out. They surge out of the negative end, race through the wire and through the bulb, and back into the positive end. And this stream of electrons flowing through the wire is exactly what we call an electric current. That current is what lights the bulb and powers your gadgets. Meanwhile, something has to keep the chemistry balanced inside. As electrons leave one side and arrive at the other, charged atoms called ions drift slowly through the electrolyte to even things out. So while electrons race around the outside through your device, ions quietly migrate on the inside. Together, they keep the reaction going. But the chemicals don't last forever. In an ordinary disposable battery, the reaction gradually uses up its ingredients. The supply of eager electrons dwindles, the current fades, and eventually the reaction stops completely. At that point, the battery is flat, the chemical energy spent, and you toss it away. Its one-way chemistry is finished. So how do the rechargeable batteries in your phone keep going for years? Their trick is that the chemical reaction can be run in reverse. When you plug in to charge, you push electrical energy back into the battery, forcing the reaction backwards. The electrons and ions return to where they started, reloading that chemical spring, ready to be used all over again. Most modern gadgets use lithium-ion batteries, and they are the masters of this back and forth. Lightweight lithium ions shuttle between the two electrodes, over to one side as you use the battery, and back again as it charges. But every cycle causes tiny wear, which is why an old phone battery slowly holds less charge, and why, if damaged, these energy-packed cells can rarely overheat. So a battery isn't really storing electricity at all. It's storing chemistry, a reaction held back waiting until you complete the circuit and let the electrons run. From the tiny cell in your watch to the huge packs in electric cars, it's all the same beautiful idea, chemical energy, released on demand, exactly when you need it. And if there's a science or tech topic you want explored next, tell me in the comments. Your question could be the next video. If this made you a little more curious about the world, subscribe to the Binary Brew, and I'll see you in the next one.